Hello everybody and welcome back to Operation Logistics, where, first things first, these quads, I think, are pretty much no longer useful. And what we're going to end up doing is we're going to end up having these origination points and waypoints have a line renderer attached to them. And this line renderer will have the material of the arrow, like so. And then we just need to go ahead and get a position here, which, let's see here, where is this? We're using world space right now, which is actually fine. Yeah, that should be fine. Then the main question is, where is the line renderer right now? Don't actually see it currently, which is a bit of a problem. Let's go ahead and remove this material and see if we can find it. Oh, it's because it's using world space. That'll be why. We do want to use world space later on, but for right now, we'll need our position to be at 0, 0, 0. So for the moment, we're just going to go ahead and have this be like a length of about 2 to go on. And then we can then just very easily add a third position here, and this would be like a position of, say, 3 and 2? 1.5? Something like that? Something kinda like that. And we could make this be like 1.5. So, I mean, obviously this is a little bit awkward right here. One thing I'm wondering is this thing upside down? What is going on with the lighting? I'm not sure what's going on with the lighting. Is it because we have light probes off? Yeah, we need to generate lighting data. So we can either stretch it like this, or we can distribute it per segment. Or rather, we can tile it, or we can repeat per segment. I'm kind of leaning towards repeat per segment right now. That's what I'm thinking, anyway. So when we look at this, we can see that there's certainly some weirdness going on. But for now, that's okay. So we're going to need to go ahead and add a similar line renderer. I'm just going to go ahead and copy the component for now to the waypoint here. We're going to paste that component as new. And of course, for this one, we would want it to only have 2 positions, and this position would be basically like that. Or thereabouts. Okay, so it would be something kind of along the lines of that. We'll just get rid of this waypoint for right now. And then in our prefabs folder, I'm going to go ahead and create a folder here, and we're just going to call this roots. And we're going to have origination point and waypoint both be a prefab. The question then becomes, do we want to have them actually have a script on them, or do we want to access that just via an overarching root script? It's a good question, but let's go ahead and create a root script right here. So root, and we'll fire up Visual Studio. There we go. Get rid of those. Perfect. Okay, so the first thing that we're going to need is the public game object origination point prefab, and then we're going to need the public game object, and this is going to be the waypoint prefab, like so. And then the question becomes, well, what do we need next? Well, we certainly need a list of the actual path taken, and that will include every hex, including the origination point and the waypoint. But first, let's go ahead and do a public vector3 origination point, and a public vector3. Actually, this will be a public list of vector3s, waypoints, like so. And then we would need to have something like a public list of vector3. This would not be the waypoints, but this would be the overall route, or the complete path. We're just going to call it path. No, not pat. Path for now. I don't think this needs start or update, but we are going to go ahead and do a public void update path. And I don't think we need to provide that any additional information, realistically. Now, we are going to need to implement a pathfinding script, and that is the reason why we spent all of that time in our hex store. Where are we? Here we are. Setting up the neighbors here. And now is the time to figure out if that's actually going to be a useful thing or not. We do need to determine if our... Like, can we only put waypoints on building hexes? And if so, how do we display that in the greater world? Yeah, that's information we're gonna need to know. The other thing that I would maybe like to do is, if we've got our origination point and our waypoint here, it's possible that we might want to have inside of here a 3D object text mesh protext. And we'll go ahead and get this rotated 90 degrees, like so. And I am going to leave it white, but we're going to go ahead and make it outlined, right? I mean, we're in the mobile distance field material right now. Is that going to affect our... I don't think it will. It did. Okay. So we would need a new material for this. So this is the drop shadow material, this is the outline material. Yeah, I think we're just going to use the outline material. There we go. And for right now, we're just going to call this root 001. This reset back to the regular material. There we go. We're going to need to change the font size substantially. It keeps resetting. What is happening here? Okay, whatever. This is fine for now. We're going to want to bring this down to around a font size of maybe 14. And then the question is, how do we want to distribute this? I think for now, let's just get this working otherwise. We'll delete the Text Mesh Pro for now, and we'll consider putting that in later on. So the next thing that we're going to need to do is we're going to need to have a public list of vector3, and this is going to be pathfind, and then we're going to say vector3. Actually, no, we're not going to say vector3. We're going to say we want hexstore.building. So we want to pass in a building. Building from building to. Okay. Now, implementing that pathfinding algorithm is going to be something that we're going to do probably in the next episode. But for right now, we'll just return null, and then just put in to do. And then the path would essentially be, we would take every waypoint. We need a way to convert from vector3 to building, though. So we need to be able to find the nearest building from point. So in our hex manager, we're probably going to want to do like an inverse of get building hex position, because that returns it in a vector 3, right? So what if we were to do something along the lines of public building get nearest building, and then we would pass in a building. Or would we pass in an int3? I think we'd pass in... No, we'd pass in a vector 3. What am I talking about? Vector 3 position. And then the question is, how will we go about finding which building is the nearest building? Well, we could just iterate through all of them and return the one that is nearest, but that's going to be super, super slow. We could isolate it down by world hex first, then by biome hex, then by building hex. That'll be substantially faster. Let's see, the worst case scenario there would be we check 2500 plus 73 plus 73, so we check like 2700 positions. That's not necessarily ideal. But I feel like that's probably going to be what we're going to have to do. And maybe instead of returning a building, we'd return an int3, and we call this get nearest hex. And then int3 equal, rather int3 ret for return equals int3.null. No, int3.null for now. And then we'll just return ret. So now that'll compile, but that won't actually do anything for us. So what we're going to want to do is we're going to want to find nearest world hex, find nearest biome hex within nearest world hex, and then find nearest building hex within nearest biome hex. So that's essentially what we're going to want to do. So yeah, we'd be looking at around 2700 comparisons realistically. The other option is that we could do a sphere cast, or an overlap sphere, and just get all of the colliders that are within a certain distance. Now that would cut us down substantially on the world hex. So I think that would be the best way to do the world hex, but we can't assume that the biome hex and building hex are currently active for that particular world hex, right? So that's the thing. Is our world hexes on a different layer? What layer are our world hexes on? They're on default. And they're untagged. I think we should go ahead and tag this with world hex. There we go. And then we would do something like cast overlap sphere for each collider in sphere. We would then say something along the lines of if tag equals world hex, then we would say something along the lines of this is in consideration. So this is in consideration. Check to see if it's nearer. So I think first thing we're going to need to do is float dist, or we'll go with nearest dist equals mathf.infinity. And then we'll go with world hex nearest hex equals no. Okay. And then check to see if it's nearer. If so, set nearest hex. And then we can assume at that point that once it goes through all of them in the sphere, which should be around 6, then it's the nearest one. And then for the biome hex, we'll just iterate through all and see what is nearest. And we're going to do the same thing with the building hex. We will iterate through all and see what is nearest. Okay, I'm going to go ahead and put a cut in here, and next episode we will implement this get nearest hex. See you all then.